Algebra 2, Module 4, Lesson 21. Margin of error when estimating a population mean. Students use data from a random sample to estimate the population mean. Students calculate and interpret margin of error in context, and students know the relationship between sample size and margin of error in the context of estimating a population mean. Lesson summary is, when using the sample mean to determine the population mean, it is important to know something about how accurate that estimate might be. Accuracy can be described by the margin of error. The margin of error can be estimated using data from a single random sample without the need to create a simulated sampling distribution by using the formula 2 times S, being the standard deviation, divided by the square root of n, where n is the sample size. Now, this is actually going to be the problem set. I'm going to do that for you. Okay, and this is a brand new hot dog claims to have a lower sodium content than the leading brand. A random sample of 10 of these new hot dog results in the following sodium measurements in milligrams. There they are. Estimate the population mean sodium content of this new brand of hot dog based on the 10 sampled measurements. So what you would do is plug that in, and right here it is. The mean of those is 314 and a half. So there would be 314 and a half milligrams. So based on the data, an estimate of the population mean sodium content of this brand new hot dog is 314 and a half milligrams of sodium. Calculate the margin of error associated with the estimate of the population mean from part A, round to the nearest 3 decimal place. Okay, so to find the margin of error, we said we're going to do 2 times, 2 times the standard deviation over the square root of n. Okay, remember that is right here. Now, so we need to know the standard deviation. So the great thing about Desmos is all you got to do is come back up here and move this. Let me do this. Change this mean here. Well, I don't know why it's not wanting to change for me. There we go. To standard deviation, and there's my standard deviation. So 24.4. We'll go 24.4. So what's 2 times 24.4? 24.4, 29.4, 29.4 divided by the square root of, now how many were they? There was 10 samples, okay? And when we do that, we get 18.617. So that is the margin of error associated with this population mean of 314.5. Okay, so the margin of error is approximately 18.617,000. Oh, that's tens. 10,000. Thousands of a milligram. So C says, the mean sodium content of the leading brand of hot dog is known to be 350. Okay, based on the sample mean of the value of the margin of error for the new brand, is a mean sodium content of 350 milligrams a plausible value? Well, we would take 314 and we would add 18.617 to it, and that would give us 333. Okay, So, no, that's not really plausible. Okay? Plausible values for the population mean sodium content are between 295, which would be the lower if I was to have subtract 18.617, and 333. So this interval is well below 350 milligrams, which is the sodium content of the leading brand. So the new hot dog brand has lower mean sodium content. Now, another random sample of 40 new brand hot dogs is taken. Should this larger sample of the hot dogs produce a more accurate estimate of the population mean sodium content than the sample size of 10? Yes, the margin of error will be smaller because you have a larger sample size. So sample size is in the denominator of the formula of the margin. That's what we talked about the other day, is why is this mathematically going to be correct? Because as this goes up, as your denominator goes up, your value goes down. Okay? As the denominators go up, the values go down. The next problem is exactly like the previous problem. Okay, we're going to find the mean, we're going to find the margin of error, understand that in context. So this says it was well known that astronauts increase their height in space missions because of the lack of gravity. The question is whether or not we increase height here on Earth when we are put in a situation where the effect of gravity is minimized. In particular, do people grow taller when confined to a bed because gravity is not working on your spine there? Okay. So a study was done in which the heights of 6 men were taken before and after they were confined to beds for 3 full days. The before-after differences in height measurements in millimeters for the 6 men were, there they are. Assume that the men in the study are representative of the population of all men. What is an estimate of the population mean increase in heights after 3 full days? So if we go back, it's 14. Here's the mean for those, and it is 14.15 millimeters after being bedridden for 3 full days. So it would have decreased by that much. I'm sorry, their heights would have increased, not decreased. Now, calculate the margin of error. Well, to do that, we would have to simply go back here, do our standard deviation, 0.939, 0.939, and we would do 2 times that divided by, how many were they? There were 6 men. Okay, and if you do that, you get 0.768. So that would be your margin of error. Now, based on your sample mean, the margin of error, what are plausible values? Okay, so plausible values, we take the mean of 14.15, subtract 0.768, and then we would take 14.15 and we would add 0.768. And when you do that, you would get the plausible value to be 14.918 and 13.382. And that is it for this lesson.